All right, today we're doing 8.1, which is where we're going to graph sine and cosine with amplitude and period changes. So we're going to learn the parent graph for sine right now. And normally when we're doing a parent graph, we pick values for x that are like -2, -1, 0, 1, and 2. But that doesn't really work for our trig function, sine, cosine, and tangent, because right here, the input is an angle. So in this case, we're using theta, but some textbooks also use the letter x right there. Just know the input is an angle. So that's why we're not using -2, -1, 0, 1, 2. It just would be a lot harder for our math. So we're going to look right here and start making our parent graph. So first we need to plug in 0. So what we're looking for is y equals the sine of 0. So what that would do from before last unit is we would graph the angle of 0. Because it's a quadrantal, we would put the point, and sine always goes with y, and the y coordinate is 0. Now, to speed things up, we have put the entire unit circle right here so that we can just pick all the y coordinates as we go around. But you do know how to do this the longer way, which was just by plugging in. Okay, so first here we have the sine of 0 degrees. So that's there. So that's going to be 0. And then if we asked you for the input is pi over 4 or 45 degrees, you would go to the 45-degree angle, which we can see is right here. And then we'd make our triangle and go from there. Again, that's review from last unit. And so the y coordinate there is √2 over 2. That's not really fun to graph. We could plug it into our calculator if we want, but we don't need it. So we'll get some other points. The next one would be right here at pi over 2, and the y coordinate is 1, so it's going to be 1. Then 3 pi over 4. Again, its sine goes with y, so we're only looking at these y coordinates. It would be the opposite part of the triangle if we drew them all. Again, this is still positive √2 over 2 because we're above the x-axis. Not really helpful. Then we go here at pi and we get 0. And then we're just going to go ahead and use that circle to keep doing that. This one's going to be -1 because when I'm at 3 pi over 2, the y coordinate is -1. This is -√2 over 2. Again, we could plug that into the calculator to get a decimal, but for our parent graph, that'd be kind of annoying to have to always do, so we're not going to do that. And then we get back to 2 pi, which is the same as 0, so we're at there. So what does this look like as a graph? So the ones we're actually going to graph are going to be these ones right here. So let's take a look. When our input is 0, our angle is 0, we're at 0. So we're right here. Then at pi over 2, we go up to 1. Then we come down to 0. Then we go to -1, and then we're back at 0. And then because you can keep going around the unit circle, this pattern is going to continue. So notice that sine starts at 0. And then it's going to go up to its 1, then it's going to go back to the midline, then it's going to go down to -1, and then at 4 pi, it's going to come back. It even goes in the opposite direction. It is a continuous function. The domain is all real numbers for the length of sine and cosine. So it could go this way and this way. So the graph actually, I'm making this really big, sorry. I'm not going to do that. That was ugly. Okay, the graph actually goes like this. Okay, so when we look at this, the 5 key points are the ones that were highlighted, and we'll work with it more in a minute. So domain is all real numbers. So we would say x such that x is an element of the reals. And if we ever do interval notation, or you remember it from math 2, that's -∞ to infinity. And the range is going to be y such that, now notice your range, it's a little different. Did you guys notice I didn't put my points all the way down here? They should be all the way down. Sorry about that. The range should be from -1 to 1 because it's trapped in between -1 and 1. Okay? Note functions that behave in such a repetitive pattern are called periodic functions. Okay, the period is the length of one cycle. So it says determine how many radians it takes for the sine curve to start repeating. So you can see it starts at 0, then it goes up, not repeating, then it goes down to 0, still not repeating because then it goes down, then it goes back up. And then if you see, now we're back at, this is called the midline right here, because you have this distance and this distance are equal from the hills and the valleys of this graph. But if you notice, now I'm back at 0, and then I have that same pattern. I go 0 up, 0 down, and then back to 0. So how long does that take? Well, the distance from here till it starts repeating is 2 pi. So the period for sine and cosine is 2 pi. Okay, amplitude is the height of the wave from the midline. For this parent function, the midline is the x-axis, so the amplitude is this distance, which is 1. The amplitude is always a positive number, so even though we go down to -1, the amplitude is an absolute value, so it's always positive. So the amplitude is the absolute value of 1, which is just 1. Okay, so before we do the same thing for the cosine function, let's go ahead and see what it would look like to graph a sine function. So this says, today we will just practice graphing with a change in the amplitude. How does A change the graph? So A, again, is the number in front right here, like we always have. In old graphs, that was the vertical stretch or compression, and it's pretty similar, except for that's just going to change our amplitude. Okay, so this is going to change the distance from the midline. Oops, who can spell? Okay, and then how does B change the graph? So the B is right here. The B is the letter B for X. That's what I always tell my students. B is B for X. And B is going to change the period. And so we know the period right now in our parent graph is 2 pi. So this is kind of like a horizontal stretch or compression, but we don't really have to look at it that way because we have a formula. B, the period is going to be 2 pi divided by B, and it's the absolute value of B. So if it's ever negative, just, and it won't be for you, but it's like that. Okay, so let's take a look. These apply to both sine and cosine, so we'll just take care of this first example. It says find the amplitude and the period. So we're first going to look for that A value, which is +6. The amplitude is always the absolute value of that number, so it's just 6. Okay, and then the period is going to be the number B for X, so the period would be 2 pi divided by 3. Okay, super easy on those. We go here and we have our amplitude, and there isn't a number, but in math, the invisible number on this case is 1. So the amplitude here is going to be the absolute value of -5/3, which is going to be 5/3. Okay, that negative will cause the graph to reflect, just like the negative has caused graphs to reflect for all of our parent graphs. And then the period, sometimes kids get tricked out by this because it says x/2, but remember that's the same thing as 1/2 of x. So the number in front is actually going to be 1/2. So when we do our math, it's 2 pi divided by 1/2, and then we're going to copy dot flip because we have more than one fraction bar, and you're not completely simplified in math till you only have one fraction bar, and then that equals 4 pi. Okay, and then for this one, we can see the amplitude is the absolute value of 1, which is 1. I always make my absolute value sign so I don't ever forget, but it's not a requirement. It's just asking you for the amplitude. And then this is, the period is going to be 2 pi divided by the number b for x. So again, this is a, this is b. So this is 3/4. Copy dot flip. So 2 pi times 4/3, which is going to be multiplying fractions, no big problem, top times top over bottom times bottom. So that would be 8 pi over 3. Okay, so let's go ahead and take a look at number 3 right here. Oh, we got some weirdo numbers, but that's okay. It goes 3, 4, 3, 4, and there was already a 3, but we'll be fine. Okay, so for this one, same thing we just did. We're going to find our amplitude, and then we're going to find our period, and that's going to help us with this graph. Okay, so this is A, this is B. Amplitude is always the absolute value of A, so it's going to be 3. And then the period is 2 pi divided by the number b for x. So that's just going to be pi. So this is going to be a little different before, so I'm just going to give you a little bit of a reminder of what our sine graph does. So our 5 points, it starts at 0, and then at pi over 2, it goes up to 1, because this is, again, just our parent graph. So in black, I'm graphing this. So this is our PG, okay? And then it comes to pi, then it comes down, and then it goes to 2 pi. So there's our parent graph right there, right? And now we're asked to graph this guy. So we are now going to take this into consideration. So our graph is going to do those same 5 points, but in half the distance. That's what the 2 is. It's smushing it. And then the height is going to go up. So the easiest way to do this is mark where your period is. So it's right here in blue. It's at pi. And then from 0 to that, make a little hash mark halfway. And then from 0 to the halfway, make 1, so that you have 4 little hash marks. Okay? And then you're just going to follow your pattern. So you're going to go 0, and then you're going to go up to the amplitude. So this case, it's 3. Then you're going to come back to the midline, or 0, x equals y equals 0. And then you're going to go to the negative amplitude, and then we're going to come back to 0. So this graph would look like this. This says only graph 1 cycle, so we can stop after that. And we know it just keeps repeating and repeating. Okay, so let's see. Anything I wanted to talk about? Just that sine goes, so it goes to the midline, or 0, then positive amp. This is our pattern for our parent graph. Then 0, then negative amp, and then back to 0. Okay, we'll graph this other sine one right here, just because it has a reflection in it. So the amplitude is going to be the absolute value of -3/2. I'm just going to think of it as 1.5. It'll be easier for the graph. And then the period is 2 pi divided by the number b for x, which is just 2 pi. So once you get that 2 pi, go mark it and then do your halves. So I did halfway between 0 and 2 pi, and then in the middle of the halves. So we've split it into quarters, okay? And then we don't ever want to forget this. Reflect over x-axis, okay? So what that does is every point that was negative becomes positive, and every y-coordinate that was positive becomes negative. So instead of going like over here, instead of going up, we're going to start by going down when it's negative. Okay, so instead of going up, we're going down, and we're going to go to each of those hash marks. So I'm going from 0, and then the first hash mark, and instead of going up, again, I'm going down because of that negative, then back to the midline. Now I'm going to go up and then back here. And that's what that one looks like. Okay, so let's go ahead and check out cosine and see how it differs from sine. It's pretty similar, but of course, now we're going to be looking at the x's instead of looking at the y's. So we want to make sure that we have everything that we need for this. So I'm going to bring down that unit circle that's right up there so I can see everything. There we go. Okay, so now we're looking at the x-coordinates for cosine. So we're going to look at that one, that one. These are the ones that are on the table down below. I'm just marking them all at the same time, a little bit faster. Okay, so look at the cosine of 0, the coordinate, the x-coordinate is 1, so that's going to be 1. And then this is going to be root 2 over 2. Again, not going to use it. This is going to be 0. This is going to be negative root 2 over 2. This is going to be negative 1. Then we have 0. Oh, sorry, negative root 2 over 2 again. Then we have 0. Then we have positive root 2 over 2. And then we get back to 2 pi, which is the same as 0. And we get back to 1. So again, our little points that we're going to be using are all these quadrantal angles because they're nice and easy right here. Okay, so let's graph those. So same thing, period for tangent is 2 pi. Period for cosine is 2 pi. So we're going to go, what's different here is at 0, we're actually going to start at the amplitude. Then we're going to come down to the midline. Then we're going to go to the negative amplitude, then come back to the midline, which is at 0, and then back up. So cosine starts at 1, and it doesn't start at the origin. It starts above the origin if it's positive, and below the origin if it's negative. And just like sine, that pattern will continue. So we start at 1, then we go down to the midline, then we would go negative 1, back to the midline, and then back up, and it just keeps. So you can kind of see it looks very similar to the the sine graph. The only thing that's different is where you start, right? So this actually says what type of transformation of the graph. Sine of x is cosine of x. So if we just move cosine left pi over 2, so here's pi over 2. If we, nope, that's not going to work, right? Because we want it to go up first. So what could we do? Oh, we can move the cosine graph that way to here, and then it would be the sine graph. So we could just do right pi over 2. Okay, so this would be right pi over 2. Okay, domain, same as the other one, x such that x is an element of the reals or all real numbers. Range, same thing as before. Negative 1 is less than or equal to y, which is less than or equal to 1. Period is 2 pi. And on our basic parent graph, the amplitude is 1. So when we go on to the next side, the thing that you just have to remember is where's my starting point? And for sine, it's the origin. And for cosine, it's the amplitude. Okay? So here we are going back to knowing the amplitude and the period. So the amplitude is the absolute value of 2, which is 2, and the period is 2 pi divided by 4, which reduces to pi over 2. So we're going to go to pi over 2. Ooh, man, we're going to be cutting that into 4 equal pieces right there so that we can get our graph the way we want it. It's not going right in the middle. User error. Okay, so now remember, cosine starts at the positive amplitude. Okay, so we're going to start at 2. And then in this first little hash mark, we come to 0, which is our midline. Then we're going to go to negative 2, back to 0, and then the midline. And always curve these, no V's. Okay, they need to be curves, not straight lines. Pet peeve, I will mark you down. All right. Also accurate math. Let's see. Here we have, negative 4. We're going to watch out for that. So that reflection, which means we're going to be going down and starting at the negative amplitude before we do anything. So absolute value, the amplitude is still 4. The amplitude is just the distance from the midline, so it's always a positive number. And then that's 2 pi divided by the number b for x, which is just 1, so that's 2 pi. So I'm going to go out to 2 pi and make sure I get my 4 little marks so I know where I'm going to be putting my points. And then because this is negative, that means we're going to reflect over x-axis, right? Which means that we're going to start at negative amplitude instead of starting at positive, okay? So we're just going to reverse it. So again, I'm just going to put cosine on here just so you guys can see. So cosine normally does this, okay? That's what it looks like on this graph. And you can see it's starting at the positive amplitude, but for this one, because it's negative, we're going to go here. Then we go back to the midline. Then we go up, back to the midline, back down. And again, curve. Okay. Let's see. Let's take a look at number 5. I left this one and didn't do it earlier because I just want you to get comfortable between switching between the two, sine and cosine. Really, the only trick is your starting place. They both follow similar patterns. So there's our amplitude and there's our period. So we're going to do, let's see, the amplitude is the absolute value of negative 1/2, which is 1/2. And the period is 2 pi divided by 4, which is pi over 2. So again, this is going to be a really tiny one. So here we are marking off those. And then also, it's got a reflection over the x-axis. And where does sine start? So we're going to start at the origin, but then we're going to go down. Okay? So we're going to start at the origin because it's sine, and then we go to negative 1/2. And then we're going to go back to the midline. Then we're going to go up to positive 1/2. And then we're going to go back to the midline. So it's just this tiny little sweep of stuff. And again, just to give you guys some comparison, this is what the sine graph looks like. So this is our basic sine graph right here. So you can see what the negative did. You can see that the 1/2 smushed it vertically. And then you can see that pi over 4 smushed it. Oh, it's not pi over 4. It's pi over 2. Smushed it horizontally. All right, last one, amplitude and period. So absolute value of negative 1 because there's an invisible 1 there. And then 2 pi divided by 2, which is just pi. So let's go to pi and cut it in half first, and then cut each half in half. And then what do we know? We're going to reflect over the x-axis, and then because it's cosine and it's negative, we're going to start with a negative amplitude, not the origin. Okay, so we're going to go to negative 1, and then we're just going to follow that pattern. So negative 1, midline, positive 1, midline, and then back to negative 1. And that's it.